So today we're going to go over our opening exercise, and what we're doing here is implicit differentiation for the following equation. The square root of xy equals x squared y plus 1. So the first thing that we want to do is revise the left side of the equation so that we have it in a power notation setting. So it's xy raised to the 1/2 power is equal to x squared y plus 1. Okay, so now we're going to take the derivative term by term, and we're going to use the chain rule, and we're also going to end up using the product rule as we do this. So first of all, taking the derivative of the left side of the equation, we're going to take the derivative of the outside function, which was that square root function, which is now written as an exponential, a fractional exponent. So if we do that derivative first, we have 1/2 multiplied by xy raised to the negative 1/2. And then we're going to multiply that by the derivative of the inside function. The inside function is xy. And in order to do that derivative, we have to use the product rule. So the product rule tells us we can take the derivative of x first, which is 1 times y, plus x times the derivative of y, and the derivative of y is y prime. So that's the first part. Now the next term is on the right side of the equation, x squared y, and so in order to do that, we're going to do the product rule again. So first let's take the derivative of x squared, which is 2x, and then we'll multiply that by y, and then we'll multiply x squared by the derivative of y, which is y prime, and then of course we have to add the derivative of 1, but the derivative of 1 is 0, so we can disregard that term entirely. So now let's rewrite the expression that's on the left side of the equation. We're going to write this as a fraction. So in the numerator we will have y plus xy prime, and in the denominator we're going to have 2 times the square root of xy. So again, we are putting that back into radical form. So that's the left side of the equation. Now on the right side of the equation, we still have 2xy plus x squared y prime. So the next thing that we're going to do, first of all, we're going to copy that last equation, and we'll paste it onto our next page. Okay, then on the left side of the equation, what we're going to do is we're going to separate this expression into 2 separate fractions. So we're going to have y over 2 times the square root of xy plus xy prime over 2 times the square root of xy. And that's cool. That's something that we can do because that's allowed by the rules of math. And then on the right side of the equation, we still have 2xy plus x squared times y prime. Now at this point, what we want to do is we want to collect all of the terms that have y prime. We want to collect them on the left side of the equation, and anything that doesn't have y prime in it, we're going to move over to the right side of the equation. So we'll end up doing it this way. We're going to have x y prime over 2 times the square root of xy minus x squared y prime is equal to 2xy minus y over 2 times the square root of xy. And so, like before, we're going to copy that last part and put it on the next page. Okay, and now on the left side of the equation, we can factor out y prime. So let's do that. So we'll have y prime multiplied by x over 2 times the square root of xy minus x squared. So that's the left side of the equation. On the right side of the equation, we have 2xy minus y over 2 times the square root of xy. Now, both in the bracket on the left side of the equation and on the right side of the equation, we're going to want to manipulate those expressions so that they have common denominators. So starting with the expression on the left side of the equation in the brackets, we're going to have y prime multiplied by, now the common denominator is going to be 2 times the square root of xy. And so now we don't have to do anything to the x, but over here with the x squared, we're going to have to multiply that by 2 times the square root of xy. So we end up with this expression. So there we have the expression that was in the brackets. Now on the other side, we're going to multiply the first term by 2 radical xy over 2 radical xy. So we're going to end up with this common denominator. And so, like I said, we're going to multiply this first term, 2xy. We're going to multiply that by 2 times the square root of xy. So we get 4xy times the square root of xy. And then we're left with minus y. Now, here's the thing. Okay, on the left side of the equation, we have the common denominator 2 times the radical, or 2 times the square root of xy. And we have that same common denominator on the right side of the equation. So we can cancel those common denominators, and we end up with y prime multiplied by x minus 2x squared times the square root of xy. And then on the right side of the equation, the 2xy in the denominator cancels, and we're just left with the numerator, which is 4xy times the square root of xy, and then minus y. And then we're going to copy this expression, this equation, and then we'll move it to the other side of the next page. Okay, so we're trying to solve for y prime. So the next thing that we're going to do then is we're going to divide both sides of the equation by the expression that is in the parentheses on the left side of the equation. So we end up with y prime is equal to, and we'll get this fraction. In the numerator, we're going to have what was on the right side of the equation, 4xy times the square root of xy minus y. And in the denominator, we'll have what was in the parentheses on the left side of the equation, and that turns into x minus 2x squared times the square root of xy. And that's it. That is the end of our problem. We have isolated y prime, which is the derivative of y with respect to x, and that's what we set out to do in the first place. So we are done with this problem.